Welcome to Bite-Sized Data Science. Up to now, we've always created models using a notebook. Notebooks are fine, but there are different types of people on a data science team that could help in selecting and testing appropriate models, but are not necessarily programmers. They could do some experimentation and then discuss them with the team in general and the data scientists in particular. The legwork they can do could save time for the data scientists to focus on more in-depth analysis. They could use a notebook and some templates and try to see which model is the most promising for a specific problem. After a while, they'd get used to it and become productive. There is a better way. There are tools available that allow people to create models without having to go through programming in a notebook. These tools can be used by more novice people. Even data scientists can take advantage of them to speed up their evaluations of different algorithms that can help solve a problem. In this video, I'm using the IBM Watson Studio environment. If you want to learn more about that platform, look at the details provided in the description to this video. The important point is that you should expect these capabilities in any data science platform you are evaluating. Let's start with a tool that is included in Watson Studio called AutoAI. The first step is to select the input data file. AutoAI then identifies the column types, as we can see here. Once a prediction column is identified, AutoAI figures out the type of model required. After we click on Run Experiment, the tool goes to work. It pre-processes the data, selects models, does feature engineering and hyperparameter tuning. Finally, it evaluates multiple solutions. We can look at the models generated and look at details such as the model evaluation, confusion matrix, precision recall curve, model information, and feature importance. Once we are satisfied with our choices, we save the model. Once the model is saved, we can deploy it, as we'll see later. The second tool I want to show still does not require programming, but requires more understanding of how to assemble a model. What I have here is an empty canvas that I use to assemble a model that will be created using Spark. We drag operators on the canvas and make small adjustments. Let's start with the input data. I drag a data asset operator onto the canvas, and then I define what it is. Here we see the data can come from a connection to a data source or a file. I'm picking a file and save the result. I can use the operators under transformation to adjust the input data to my needs. In our case, the data is just fine, so we can move to the modeling operators. I have a choice of 11 modeling operators. I pick the one I want and connect my data source to it. I need to make a few adjustments to my modeling operator. Since I'm using a supervised model, I identify the target column and then pick the attributes that I want to use in the modeling. I could make changes to the advanced parameters, but for this demo, I'll use the defaults. Once the modifications are saved, I can generate the model using Run. Once the model is created, we can look at how it did. The data provided is similar to what we could extract when we created the model in a notebook. Finally, if we are satisfied with the results, we can save the model and later decide if we want to deploy it. In the case of Watson Studio, we have the additional choice of being able to assemble a model using the SPSS modeler environment. We create the model in a similar manner, but this time we have more operators in our toolbox. With the Spark environment, we have 7 transformation operators and 11 modeling ones. With SPSS, we have the equivalent of 30 transformation operators and 45 modeling ones. Just like we saw in the previous video, we can deploy the model through a simple interface. Once the model is deployed, we can use the interface either programmatically or through Watson Studio to score some records. Just like with the decision tree model that we created in the previous video, this deployed model can take either a form or a JSON document. The result is a JSON document that includes the data and also the response to the scoring. Having this type of interface to create and test models speeds up the testing of models, but, more importantly, it provides the ability to more team members to be more productive. It also speeds up the communication between team members. When looking at a data science platform, make sure to look at the tools provided to make model development easier. See you next time on Bite Size Data Science, and don't forget to subscribe.